Hello students, in this video we will see MCQs on semiconductor. First one, the conduction band in a solid is partially filled at 0 Kelvin. The solid sample is conductor, semiconductor, insulator, none of this. So as you know, at 0 Kelvin conduction band is filled or partially filled only in conductor. In semiconductor and insulator, valence band will be full, but conduction band will be empty. Second one, the valence band and conduction band of a solid overlap at low temperature. So conduction band and valence band are overlapping. So means forbidden energy gap is 0, that is observed in metal. Third one, in an insulator, forbidden energy gap between valence band and conduction band is of the order. So you should know, in just second question we had, in metals forbidden energy gap will be 0. So forbidden energy gap in metals is 0. In semiconductors, forbidden energy gap will be around 1 electron volt. In insulators, forbidden energy gap will be greater than 3 electron volt. So here he has asked in insulator. So if you observe the options, D is the answer, 5 electron volt. Fourth one, forbidden energy gap in conductors, semiconductors and insulators are Eg1, Eg2 and Eg3 respectively. The relation among them is, so just in previous question I told, forbidden energy gap will be less in conductors and will be maximum in insulators. Means Eg1 should be less and Eg3 should be more. So here you will have Eg2, so less than. Now observe the option. Option B is the answer. Eg1 is less than Eg2 is less than Eg3. Fifth one, doping of intrinsic semiconductor is done to neutralize charge carriers, to increase the concentration of metal charge carriers, to make it neutral, to carry out further purification. As you all know, doping is done to increase the conductivity, means to increase the concentration of majority charge carriers. Sixth one, the majority charge carriers in p-type semiconductor is, everyone knows this one, so holes are majority charge carriers in p-type. In n-type, electrons are majority charge carriers, while in p-type, holes are majority charge carriers. Seventh, a p-type semiconductor can be obtained by adding arsenic, gallium, antimony, phosphorus. So as you know, in p-type, so doping is done by using trivalent impurity. So by using trivalent impurity, and trivalent impurity we use like indium, gallium, aluminium, etc. So here if you observe p-type, arsenic, antimony, gallium, phosphorus, means answer is B. Similarly, in n-type, we will be using pentavalent impurity. We will be using pentavalent impurity, right? Here only in options A, C and D you are having like arsenic, antimony, bismuth, phosphorus. So these n-type by adding these impurities, p-type by indium, gallium and aluminium. Eighth one, in p-type semiconductor, the majority and minority charge carriers are. So in p-type, majority charge carriers are holes while minority will be electrons. Now check the option. Option D is the answer. Ninth one. The charge on a hole is equal to that of charge of a proton. Hole we think it is positive, so it will be equal to that of a proton. Tenth, if Ne and NH represent number of free electron density and hole density respectively in a semiconductor for n-type semiconductor material. So for n-type, electrons are majority charge carriers, means density of electrons should be very much greater than density of holes. So if you check the option, B is the answer. 11th, when a semiconductor is heated, its resistance. So in semiconductor, as the temperature increases, resistance decreases. So when it is heated, its resistance decreases. Resistance decreases. 12th one. Which of the following has a negative temperature coefficient of resistance? So which has a negative temperature coefficient of resistance, means alpha is negative. So alpha is positive for metals. So copper, iron, aluminum, these three are metals. For semiconductors, alpha is negative. So means option D is the answer. Option D is the answer. 13th, in depletion region of unbiased PN junction diode, there are. So if you take a PN junction, near the PN junction, you will be having immobile ions. Here you will be having immobile ions near the junction. So if you check the options in depletion region of unbiased, there are only fixed ions. So immobile ions will be there. 14th, the cause of potential barrier in a PN junction diode is. So potential barrier around PN junction will be due to depletion of positive charges near the junction, concentration of positive charges near the junction, depletion of negative charge near the junction, concentration of positive and negative charge near the junction. So near junction you will be having both positive and negative charges. So option D is the answer. 15th, in forward bias arrangement, PN junction diode, N is connected to positive terminal of the battery. Wrong. So if you take PN junction in forward bias, P is connected to positive terminal of the battery while N is connected to negative terminal of the battery. So N is connected to positive, this is wrong. P is connected to positive terminal of the battery. Option B is the answer. In forward bias, the width of potential barrier in a PN junction diode increases, decreases, remains constant, first increases and then decreases. So now in forward bias, there will be flow of current. So charges move towards the junction, few diffuses, so the barrier goes on decreasing. 16th, so potential barrier decreases. 17th, on adjusting PN junction diode in forward bias. In forward bias, depletion layer increases. No, depletion layer decreases. Resistance increases. No, resistance decreases because there will be flow of current. In forward bias, there will be flow of current, and in reverse bias, it acts as a very high resistance. See, both decreases. This is correct. In forward bias, depletion region ಕಮ್ಮಿ ಆಗ್ತದ್ರಿ, ರೆಸಿಸ್ಟೆನ್ಸ್ ಕಮ್ಮಿ ಆಗ್ತದೆ. ಯಾಕಂದ್ರೆ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗ್ತದೆ. ಸೊ therefore answer is C. The reverse biasing in a PN junction diode. So forward bias ಒಳಗೆ ಡಿಪ್ಲೀಷನ್ ರೀಜನ್ ಡಿಕ್ರೀಸ್ ಆಗ್ತದೆ, ರಿವರ್ಸ್ bias ಒಳಗೆ ಡಿಪ್ಲೀಷನ್ ರೀಜನ್ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತದೆ. So if you read the options, increases the width of potential barrier. Option B is the answer. 19th. On increasing the reverse bias to a large value in PN junction diode current. So if you take the graph of forward bias and reverse bias, so ikkade V, ikkade current in microampere, so you will be having graph in this form. So on increasing reverse bias to a large value, so voltage ikkade left ge ಹೆಚ್ಚು ಮಾಡಿದ್ರೆ ಅಂತ ಹೇಳಿರಿ. If you observe, the current has increased drastically. So current increases slowly, remains fixed, suddenly increases, decreases slowly. Option C is the answer. Suddenly increases. PN junction diode is used as a, so PN junction, it is used as a rectifier. It is used as a rectifier. Clear adare? Hope it is helpful to you. So ಆದಷ್ಟು ನಿಮ್ಮ ಫ್ರೆಂಡ್ಸ್ ಜೊತೆ ಶೇರ್ ಮಾಡ್ರಿ. Ask them to subscribe the channel.